Hello again. I am in fact also Augusto. This this time he chose a less qualified representative, but yeah, you'll have to bear with me here. I'll talk about alternation-based novelty search, which Augusto and Jendrik developed. So the setting this time around is agile planning. So we don't care about plan quality at all, and the only measure is that we want to find a plan as quickly as possible. And the faster we do that, the more we get rewarded. And in the past two IPCs, the results were a bit unsatisfying, maybe, in that not the previous one, but the one before that, only best first with search planners beat the Llama benchmark, the Llama baseline, sorry, and in the most recent IPC, Llama even outperformed all the actual participants of the competition. So the kind of approach of this Augusto and Jendrik here was to combine the strengths of this best first with search approach with Llama to see whether they can come up with a combination of the two that actually improves the state of the art. Yes, and first let's look at the two components, Llama and best first with search. Llama has existed for a while, and as we saw in the last competition, it still seems to be state of the art. Llama by itself is really an anytime planner, so it would continuously improve plan quality as you let it run. But in this agile setting, we of course don't care about that. So really we're only looking at the first component of Llama, which just finds one solution and returns it. And the way it works is, or one of the major ideas in Llama is that it has these alternating open lists where it uses two heuristics, FF and the LM count or LM sum heuristic, and two versions of each. One where it's just regularly ordered by the heuristic value, and one where we only care about states that are generated by preferred operators. So we end up with these four different open lists, and what Llama does is just expand or pop a state from each of the open lists in this kind of round robin fashion. It just pops from open list 1 and then 2 and so on, and until it finds a solution. And the second kind of idea that seems to do well in this agile setting is best first with search, which can be implemented in different ways, but the kind of crucial concept we'll focus on in this talk is novelty, where the idea is that we want to prefer states where we see a new atom or a combination of atoms that we haven't seen before. And the usual way in which this is done is using a width of either 1 or 2. So we either only look at single atoms that we've never seen before, or in the case of k equals 2, we also consider pairs of atoms that we have never seen before appearing together in a state. And using that, we will prefer states that are more novel, so that contain atoms that we've never seen before, or pairs of atoms that we've never seen before. That's kind of the second idea that we want to combine in our alternation-based novelty search. Okay, so the one specific implementation of best first with search is F6, or is called F6, where we have a single open list that has some different tie-breaking components. Starting first with, I can click, with the actual width part, where we consider novelty, but it's not. We don't compare the novelty of states of all the states in the state space, but we have this important notion of partitioning the state space, and then only comparing novelty within partitions of the state space. And the way it's done in F6 is to partition according to the same landmark count or sum heuristic and the FF heuristic that we've seen in Llama as well. So that means we only compare the novelty of states that match in terms of heuristic values of these two heuristics. So within one partition, we look at we compare the novelty within that partition. And then we also have this preferred component as the second tiebreaker, which also is similar to Llama, where we only consider the successors that have been generated with a preferred operator. And yeah, another novelty component here where we partition only according to FF and not, so the partitions will be bigger. So this is F6 is one of the configurations of best first with search that works really well in practice. Now, given these two things that work well, how can we combine them? But okay, this will be the next thing. But first, we want to see how did Augusto and Jendrik approach this problem? How did they figure out how to combine them? Because they restricted themselves a little bit by kind of pretending that they're preparing for these competitions. So what they did in particular is partition the sets of the benchmarks into the ones that were known before the 2018 competition and the ones after. So they only, when running experiments to optimize their approach, they only used the training set, so to speak. So only the benchmarks that were known before the 2018 competition, and then they evaluated on the competition benchmarks from the last two IPCs. And this is essentially to be more fair to the existing approaches by not using more information to optimize their approach than was known at the time. Okay. So one thing I've mentioned about BFWS is this parameter k, where that tells us what the largest tuple size is that we consider for novelty. And in practice, k is mostly chosen to be either 1 or 2. But what Jendrik and Augusto figured is that choosing this statically is maybe not the best way to do it, and they wondered whether we can do that dynamically. And they ran some tests to see. Okay, so the thing is that the problem with choosing k to be 2 is, of course, more informative. But if the task is large, then you can run into the problem of this being too expensive. So they ran some tests for different sized tasks, indicated by the number of variables that the task contains, and saw that using a fixed k is worse than switching over from 1 to 2 when the task contains more than 100 variables. So yeah, this is what they found evaluating on the test set, that if we transition at that point, if the task is larger than 100 variables, then we will stick to k equal 1, and below that it's feasible to use k equal to 2. So that was the first kind of optimization they did to improve the performance. And now, like the meat of the idea is to combine these two ideas of BFWS and Llama. And as we saw before, F6 is one type of open list, a single open list that works well for when we do BFWS. And one kind of most natural idea would be to add this open list to this round-robin alternating idea of Llama. But as you can see, the spoiler here is that this is doesn't work well enough by itself. And so Jendrik and Augusto, they thought more about it, and they figured they would try to take simpler versions of F6, so not containing all the tiebreakers we've seen before, but reducing this relatively complex tiebreaking structure and seeing if individual components work better, and using those to enhance Llama. And yeah, here I want to note that these simpler components are also not new in that sense. Like this previous work on BFWS also describes some simpler versions than F6, which would be called F4 and F2. So these are not new ideas in that sense, but just Augusto and Jendrik evaluated some of them and saw in practice which ones of them enhance Llama. And yeah, so the important bits in this graph, I suppose, is Llama itself in orange, which is still quite good. So what we're seeing is coverage over time. So we want the graph to rise as quickly as possible and end really high. So the timeout will be the 5-minute timeout that is used in the IPC. And Llama still performs quite well, better than some of the components where we only use FF, for example. And the other interesting one is the light blue graph, the light blue plot, where we enhance Llama with the F6 open list. So this is Llama WF6, which is essentially the same as Llama itself, and it even, if you look at the left, it's a bit slower for small tasks. But what really worked well is, for example, the red plot, where it's a simpler BFWS configuration, where we only look at the LM count heuristic, and we do width or novelty by partitioning on the landmark heuristic. And then, yes, the second tie-breaking, I think, is the heuristic value. So that is the one enhancing Llama by that open list seems to perform really well. Okay, so this is the one that they gave a name to, which we have the same for open list from Llama, and we enhance it to with this BFWS open list. And this is called Nolan, and of course every acronym needs some kind of justification. So there you go. It's called Nolan. So far we looked at the training set. So we saw that on the training set that this works well, but now we want to compare on the new IPC domains and see whether it actually beats the participants and the baseline of these competitions. And as you can see, Nolan has more coverage than the Llama baseline, and also some of the best competitors of the competitions, both in terms of coverage and also agile score, which again you get more score if you solve a task quickly. Right. Yeah. So to wrap up, we've combined Llama with a novelty-based open list, and we got good results, better than the IPC participants. And doing the simple thing by just using F6 is not good enough. And as a very final note, one kind of fun fact that Augusto passed on to me is that Nolan is also interesting in that sense because it's one core idea of the Scorpion MyDo planner, which participated in the satisficing track and actually won. So it's not only in the agile setting where this is interesting, but also as part of the satisficing track winner, Nolan was one of the key ideas that brought success there. So with that, thank you very much for your attention, and you can try questions, but we'll see.
Do we have any questions?
Thank you for your talk, Augusto.
No worries.
So, do you know if they used boosting, and if so, if that indicated the activity of each open list.
I don't remember reading anything about boosting in the paper, so I don't know if it was within the BFWS open list, you mean? Or
within the Llama framework, that when you alternate, sometimes you give more preference to the ones that are making more progress?
I see. Yeah, I assume they would use the way they did it in Llama. They didn't mention changing that, at least, yeah, from what I remember.
Right. Any further? Any more? I mean, I also had a question, but I think it's more actually probably should direct it to Nir. Just in the BFWS F6. So just to clarify, with all these type ranking conditions, they're sorted in Lex order, right? So the first one matters more.
Yes.
So essentially, if I understood this correctly, it's saying that a novel state with a worse heuristic value is ranked before an unnovel state with a better heuristic value. Is that a correct interpretation?
Correct. So you prefer states that have a smaller novelty? So interpret the novelty as a rank.
Yeah.
And the order is not accidental, because it helps. Let's say within the you think about landmark as doing goal counting, and it helps you do backtracking across different goal counting regions that you're in a plateau. So we're trying to emulate that within the same plateau, you try to first prefer the novel states, and then if that doesn't work within the same plateau, we also use the FF heuristic to guide you within regions that have the same landmark counting. So you achieve this by doing this exact order.
All right. So any last questions? No? All right. Well, thanks to all the speakers. And